Thank you for the introduction. I'm pleased to present at the Embedded Vision Summit today. And in this presentation, we will start with a simple problem definition, followed by how blind super resolution fits into this and tries to solve the problem for real-world examples, provide some insights into our optimized model structure, and end with some visual examples. Yes, let's start with the definition of super resolution. So super resolution is a pretty straightforward task where we have a low resolution input image and we want to produce a high resolution version of the image. And that's basically the whole idea. Now, what's the relation between the two images here we see on the slide? Well, we assume that every pixel in the low resolution image was generated from the surrounding pixels in the high resolution image. And these areas are connected by a blur kernel K and subsampling alpha, meaning K runs on the high resolution image and produces from a specific amount of pixels a single pixel in the low resolution image. And this is obviously a high ill-posed problem, even if we know this kernel. Even if we have knowledge about it, this is highly ill-posed because we want to produce more pixels than what we have in our hands. And it turns out that currently the best methods that do image upscaling nowadays obviously use deep learning such as EDSR and RDN. But both methods use very complex and sophisticated networks and actually also assume a lot of knowledge about this kernel K. Not only assume knowledge about it, but also the method assume it's constant across all the images in the world. But it turns out when this assumption does not hold, like for images that are not part of the training set or the test set, so images in the world, images we take with our smartphone or we download from the internet, those methods perform poorly. And this phenomena gave rise to what's now called in the field of machine learning blind super resolution. And blind super resolution, all it does is it assumes explicitly that we do not know the kernel. So blind super resolution has no prior information about the kernel. And in this presentation, we approach this question mark here and also show that based on that, we are able to design a much smaller network that can, if optimized, run on a resource constrained device.